Good morning, students. Today we are going to do the chapter from the book Geography, and the chapter name is Rotation and Revolution. Now, as we have already discussed about the effect of rotation on the earth, so our present concentration on this chapter will be on the revolution of the earth. So, how will you define revolution, or what is revolution? Revolution is the movement of the earth around the sun. In a fixed orbit. Now, now, what are the effects of rotation? Now, before that, we have to keep in mind that the orbit is not a circular path, it is actually a spherical path. And because of the spherical path and the tilted movement of the earth, or the tilted position of the earth, there are various features which affects because of this revolution. Like, first of all, it takes, for the entire revolution of the earth, it takes 365 days and some 6 hours. Now, for every year, these 365 days and 6 hours, and these 6 hours is added for the 4 consecutive years. And when we add this 6 hours for 4 consecutive years, we get one leap year. So at the end of every 4 year, we get 24 hours extra, or one day is getting added with this 365 days. That gives 366 days, and we form a leap year. So this is the first feature of revolution. The second feature of revolution is the speed. You will be surprised to know that the earth revolutes around the sun at a very nominal speed of 29.8 kilometers per second. Yes, you have heard it right. It is 29.8 kilometers per second, the speed of the earth. Or if you see it in otherwise, it is 107.2000 kilometer per hour. This is the time, or this is the speed of the earth to revolute around the sun. And the third most important feature of revolution is the change in seasons. Now, for the change in seasons, actually, the tilted position of the earth and the spherical or oval shape of the orbit helps to form the helps to form these changes in the seasons. Now, how these changes in the seasons occur? The entire formation of the change of seasons can be illustrated by one single and simple diagram. Suppose this is the sun over here and the earth is present at this position. Now, as we know that the earth's position is little bit tilted, so we will draw it like this, and we have the two poles over here, north pole and south pole. Now, during this position, what happens? Let me draw the equator for you, and we have the Tropic of Cancer and the Tropic of Capricorn. Now, when the earth is in this position, you can see that the Tropic of Capricorn directly faces the sun. The Tropic of Capricorn directly faces the sun, and in this position it is summer. In this position it is already summer in the northern hemisphere, and we have the summer season in the northern hemisphere. Now remember, India lies in the northern hemisphere, so whatever we are learning in this diagram will be based on India. Now if you have to just find out the climate of, or find out the season of the southern hemisphere, it will be completely reversed than what it is having in the northern hemisphere. So as we have seen, the northern hemisphere will have complete summer season over here, and in this position on June 21, you will have a solstice which is called summer solstice. Now, what is actually a summer solstice? Summer solstice means you will have the longest day time and the shortest night time. That means on June 21st you will have sun rays, or you can see the sun, or you will have the daylight max for the maximum period of time. Now after 3 months the earth will come to this position, and obviously I cannot show you that other side, we can only illustrate it, and this side will obviously it will be night on this side, but whatever, if you see this side of the, when the earth comes in this position, it the equator of the earth faces the sun, that is the sun rays falls directly on the equator. That means at this point of time we will have neither summer nor winter. So this season will be called autumn. And on September 22, we will have autumnal equinox. Equinox means you will have equal day and equal night. So on September 22, you will have equal day and equal night, which is called autumnal equinox on the northern hemisphere. Now again, after 3 months, the earth will reach in this position. And when it reaches this position, now you can see that the northern hemisphere is actually far away from the sun, and the sun rays falls directly on the Tropic of Capricorn. See, the sun rays falls directly on the Tropic of Capricorn. So this position is giving rise to the winter season in the northern hemisphere. Winter season in the northern hemisphere. And on December 21, you will have winter solstice. Winter solstice. Now, what do you mean by winter solstice? Winter solstice means you will have the more hours of night than daytime. The daytime will be short and the night time will be higher. Now again, after 3 months, the earth will reach in this position. And again in this position, neither the northern hemisphere nor the southern hemisphere will face the sun. It will actually, the equator will face the sun directly, or the heat of the or the rays of the sun will fall directly on the equator again. And this season will be the spring season. It will be in the month of March, and March 20, on this date you will have spring equinox. Spring equinox means again we will have equal day and equal night. And after that again, it will come back to this position, and by this way it will complete a 1 year revolutional cycle. So now we got all the different seasons in the northern hemisphere. For example, we got summer, we got autumn, we got winter, and we got spring. These are the four main seasons geographically. So hope you have understood the changes in the seasons and the occurrence of the seasons by this simple diagram. So this much for today. Hope you will read the chapter, and if you have any doubts, you will ask in the comment section. Thank you.